All right, so this is video 3, starting with question 11. We want to write the equation of the axis of symmetry. So we should know that the equation for the axis of symmetry is simply x equals the x value of your vertex. So what you need to do is find that x value of your vertex using the formula negative b over 2 times a. And when you use that formula, please write it with parentheses negative b over 2 times a. Identify your a value, which is 6, your b value, which is 8, and your c value, which is negative 13. So we're going to plug in the b value of 8 right in here, and the a value of 6 right there. So what do we have? We have the equation x equals negative 8 over 12. Now, if we were taking an open response final exam, I would give you full credit for this. That's the correct answer, but on the multiple choice, you're not going to see that answer. You need to reduce that fraction, and that will be the equation x equals, if you reduce by 4 and reduce by 4, that will be negative 2 over 3. That is your axis of symmetry equation. That would be the vertical line crossing through the vertex. You don't have to find the entire vertex. All you're doing is finding the equation of the axis of symmetry, and that's it. X equals negative 2/3. Let's move on to number 12. It says solve. So how do we solve a quadratic trinomial equation? You could try to factor, split it, and solve it. But because the a value is not 1, I'm not even going to attempt to factor unless I want to use that long method of factoring, of step 1 being a times c, step 2 thinking of the multiples of that number that combine together to give you the middle value b. Or you could go with the quadratic formula. I don't know, what do you guys think? Should we try to factor it, or should we use the quadratic formula? Factor? Okay. Now, if you do look at your multiple choice test and you see that there's square roots involved with the plus and minus, then that should be a hint for you to go with the quadratic formula. But let's try to factor using the long method. Step 1 was to multiply a times c, where a is 3 and c is negative 10. When I multiply those, it'll give me a negative 30. And then step 2 is to think of the multiples of negative 30, like negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4, negative 5 times 6. Those are all the possible multiples of negative 30. And we need to see which pair of numbers combines together to give us the b value, which is negative 13. Now, if we do combine the negative 2 and the positive 15, we get a positive 13, and we know we want a negative 13. So my pair of numbers is really a positive 2 and a negative 15. Right? We had the right numbers, we just had the wrong signs, so we changed the signs. Now, step 3 on this long method of factoring is to plug it into your factored form format, and we write whatever we see here, we write it twice. We write the ax term. So we put a 3x right here and right there. This is kind of weird, putting a 3x here and a 3x there, because we know that that can't be the final answer, because 3x times 3x is not 3x squared, it's 9x squared. So that's why it's important to remember step 4 of reducing your binomials. Anyway, we take the pair of numbers from step 2 and simply plug them in. Positive 2 here, negative 15 over here. Like I said, step 4 is to reduce by your GCF. Now, on this first binomial, there's nothing in common, so you can't reduce it. In the second one, you could reduce by 3. So divide by 3, divide by 3. You will have 3x plus 2 times x minus 5, and it's still equal to 0. So there's my equation, 3x plus 2 times x minus 5 equals 0. And I know that I'll be able to split it now because of the zero product property, split it to 3x plus 2 equals 0, and also x minus 5 equals 0. Once again, when you have something times something, and if it equals 0, then the first something could be equal to 0, and the second something could be equal to 0. So now we solve those two simple equations. Subtracting 2, we will have 3x equals negative 2. So my final answer, if I divide both sides by 3, is negative 2/3. And that is one answer. And over here, if I add 5 to both sides, I have my other answer of 5. Those are my two answers right there. Now, if you're thinking, man, that's a long process, I totally forgot how to factor, you don't need to remember all those steps. You could jump to the quadratic formula. So I might as well throw that at you right here on this one. So here's an alternative way of doing it. So I just wrote the quadratic formula up here, And then I'm going to replace all the letters with parentheses. And then we plug in those A, B, and C values. So the B value is negative 13. And the B value is negative 13. The A value is 3. The C value is negative 10. And the A value is 3. So with the calculator, let's work on the discriminant value. The discriminant value, you start with the negative 13 squared. That's 169, I believe. So in here we have 169. And then we have 4 times 3, that's 12, times 10, that's 120. And a negative here times a negative is a positive, so that's positive 120. So I'm going to add 120 to it, plus 120. And it's still over 6 with the plus or minus in front of the square root with the positive 13 out at the side. And 169 plus 120 is 289. And if we do the square root of 289, we will get 17. So let me write that out. So there it is. We have 13 plus or minus square root of 289. And we know that 289, the square root of that is really 17. So we really have 13 plus 17 over 6 and 13 minus 17 over 6. That's a plus or minus. So I really have 30 over 6, which equals 5. And I also have negative 4 over 6, which only reduces down to negative 2/3. So there are two answers, 5 and negative 2/3. As you can see, we had the same answers over here, 5 and negative 2/3. It's totally up to you if you want to go with the quadratic formula or if you want to factor, split, and solve. And on number 13, they're asking us to factor, okay? So what's the first type of factoring that we learned, and what's the first type of factoring that we should always try? GCF. So looking at 42 and 70, I know that there's a 2 in common, but there might be something greater. 7 is a greater value. So let's put parentheses right here. Let's put a 7 out here. Now the reason why I left space is because not only does it have the 7 in common in both, but it also has variables, x and y's. So what's the maximum amount of x's we could pull out from both at the same time?
1.
Only 1x, right? So let's put a 1x out here. And how about the y's? What's the maximum amount of y's I could pull out from both of these at the same time?
1.
Only 1. Even though it has 3 here, there's only 1 y here. So the maximum amount of y's you could pull out from both at the same time is simply 1 y. So your GCF is 7xy. Now, if you didn't see that there was a 7 in common, if you pulled out a 2, then you would have a 21 left and a 35, and then you would see that you could still pull out an additional factor. So anyways, there's our GCF. What would be left over on the inside? 7xy times what gets us a 42x squared y?
6x.
Okay, so 7 times 6 is 42, so let's write down a 6 right in there. And then x times what is x squared? X, that's right, so 6x is it. And the y, you don't need to multiply it by anything. You could put a 1, but that would be pointless. Y times 1 is y. So it's just 6x in there. And then 7xy times what will give us a negative 70xy to the third. So 7 times what is negative 70?
Negative 10y squared.
Negative 10, and one step at a time. So x times 1 is x. Y times y squared is y to the third. So let's put a y squared right there. Wait, did I mess up? Wow, I did mess up. Yeah, I messed up because I did not pull out the GCF. We thought it was 7, but as I'm looking on the inside, 6 and 10, what's in common there? 2. So I can pull out a 2 also. So I should have pulled out a 14, right? But even if you make this mistake like I just did right here, let's pull out an additional 2. So if I have the 7xy and I pull out a 2, I need to multiply the 2 times 7, right? But let's pull out that 2. What would be left if I pull out a 2? Instead of 6x, what would I have? 3x. And if I pull out a 2, minus 5y squared. So all I need to do now is multiply 2 times 7 and get 14xy. What would I have left? 3x minus 5y squared. And that is the answer to that one. So I guess I'm kind of glad I made that mistake. I thought the GCF was 7, but then I looked at the inside. I saw a 6 and a 10. Both of those are divisible by 2. So you pull out that additional multiple of 2 and then multiply it by 7. So you get your GCF, which is really 14xy, not 7xy. Let's move on. Number 14, there was a typo right there. Please change that second a squared to a b squared. My bad. It doesn't make sense to have a squared times a squared. That'd be a to the 4th. So let's change to a squared b squared. Another typo that I made. I apologize. Anyway, we are multiplying, and we have to remember the rules of exponents. When you're multiplying two terms with the same base, you add exponents, right? X times x is x squared, right? But in this case, a to the 7th times a to the 2nd, what do we get? A to the 9th, because 7 plus 2 is 9. And then let's go for the b's. B to the 7th times b to the 2nd, what is that? B to the 9th. And that's it, we're done. You see, it's easy. A to the 9th, b to the 9th. Number 15, solve. I love solving equations. It's so much easier than graphing or all that other stuff. How do we solve? We want to get the variable by itself on one side. How do we get rid of stuff? We do the opposite of what we see, right? So if you had a plus 3, you get rid of it with a minus 3. If you have a 5x, like 5 times x, you get rid of the 5 times by dividing by 5. Now right here we have an exponent of 2. We have a second power. What's the opposite of the power of 2? Square root, right? The square root undoes the square. So if we apply a square root here and apply a square root there, we will have w minus 9 equals, now because we took the square root of something in an equation, we have to put a plus minus in front of our answer, and the square root of 16 is 4. So I have w minus 9 equals plus or minus 4. So I almost have w by itself. All I need to do is get rid of that minus 9. So I'm going to add 9 to both sides. Now notice, I'm not going to actually do this 9 plus the plus or minus 4. I'm going to write it twice, okay? So on the left side, I do have w all by itself. On the right side, I have the positive 9 and then plus or minus 4. Now the plus or minus produces two answers, and we need to actually do this to identify it on our multiple choice answers on the final. So we have 9 plus 4, which is 13. That's one answer. And we also have 9 minus 4, which is 5, which is the other answer. Get it? Okie doke. 16. It says graph. And do we end up with a line, or do we end up with a parabola, or what do we end up with? Parabola, because it's a quadratic equation. Now there's two ways of looking at this. You could look at this as the standard form, where you say, oh, I'm going to find the vertex by doing x equals negative b over 2 times a. What is the b value here, guys? There is no b value, right? There's an ax squared. The a value is negative 1. There is no bx. So the b is technically 0. The c value is 2. So when you plug in negative b over 2 times negative 1, you're going to be plugging in a 0 for b, which means that your x value, 0 divided by anything, is still 0. So your vertex x value is 0. And it's really easy to plug in a 0 into this equation. What's your answer if you plug in a 0? And let me actually reiterate what we're supposed to be doing here. Once you find your x value, how do you find the y? You plug it in. So we're plugging in 0 squared minus 0 is still 0. 0 plus 2 is 2. So 0, 2 is the vertex. Let's go to 0, 2 and put a big fat dot right there. So we're supposed to draw our axis of symmetry right through here, but the question was just asked, what if I wanted to see this in vertex form? Okay, vertex form is y equals a parentheses x minus h squared plus k. And obviously this doesn't look like that yet because there are no parentheses around the x. If there is one single x only, if I had a 2x, I wouldn't be able to do this, but because there's only one single x right here and it's squared, we could kind of like force some parentheses right there and then make it look like this: y equals -1 parenthesis x minus 0 squared plus 2, and then now it's in vertex form, and you could get that vertex HK02, which is the same exact vertex that we found the other way. So it's totally up to you whether you want to look at it in standard form, use a formula to find the vertex, which is really easy because the b value is 0, or you could change it to look like vertex form just as easy. I don't know, whatever you feel more comfortable with. Anyways, either way, you're going to find this vertex. What do you do immediately after you find the vertex? You draw the axis of symmetry right through it, the vertical line going right through it. Now we need more coordinates. Because this a value is -1, we could use a pattern 1, 1, 2, 4, 3, 9, and we don't have to modify it. And it is opening down because it's negative. So I'm going to go 1 over 1 down and put a dot right there. And then I'm going to go back to the vertex and go 2 over 1, 2, 3, 4, put a dot right there. And then I'm going to go 3 over 1, 2, 3, 9 down right there, almost to the edge. And then I'm going to map them over to the other side. And there's my beautiful looking parabola that opens down because the a value is negative. And we could answer a couple more questions about this graph. 16b, what is the equation of the axis of symmetry? Remember, the equation is simply x equals, and you have to write x equals, it's the vertical line, that red dotted line I drew right through the x value of the vertex, and that gives it away. What is the x value of the vertex? 0. So your equation of the axis of symmetry is x equals 0. How about the domain? We should all know x equals all real numbers because the parabola does go to the left and to the right forever. And when we take a look at the range of the y values, and as you can see, this parabola, it exists down here at -8, it exists at -5, at -2, at 0, at 1, at 2. It doesn't exist at 3, it doesn't go above 2. So with regards to the y value, the maximum height is at 2, and everything else is below 2. So how do we say that in an inequality? Y is what? Less than or equal to 2. Boom. Let's move on to number 17 here. State the discriminant. What is the discriminant? The discriminant is b squared minus 4ac. That's the value inside the square root of the quadratic formula, just the b squared minus 4ac. Now, the discriminant will tell you if you have one answer, two answers, or no real answers. Or you could think of it visually. The discriminant will tell you if the parabola doesn't cross the x-axis, that would mean no answers. Or if it touches the x-axis at one point, that means it has one real answer. Or if it actually crosses the x-axis at 2 points, it would have two real answers. In order for you to determine this, you need to find out the discriminant. But in order for you to find out the discriminant, you have to have your quadratic trinomial equation set equal to 0. You don't want it equal to 15. So let's first subtract 15 and subtract 15 and rewrite it. We're going to have 4x squared plus 7x minus 15 equals 0. And now we could see our a value is 4, our b value is 7, our c value is negative 15. And let's use this discriminant right here, but we're going to replace it with parentheses, replace the variables with parentheses. Now keep in mind, this is the value, if you were to do the quadratic formula, the value that's inside your radical, inside your square root. So what's the b value? 7. The a value? C value? Negative 15. So you can do this with the calculator. Just be careful typing everything in precisely. 7 squared is 49. And then 4 times 4 is 16. And 16 times 5, I'm going to actually do that on the calculator, times 16 times 15. I'm sorry, 16 times 15 is 240. Thank you. Now this is positive 240 or negative 240? Positive. Because a negative times a negative is a positive, so plus 240. Let me do it in black, stay consistent here. So what is 49 plus 240? It's 289. Okay, so the discriminant is 289. If I were doing the quadratic formula, I would end up with the number 289 inside the square root. The number positive 289 inside the square root. Now that tells us a lot. If that would have been a negative 289 inside the square root, you wouldn't be able to do it because the square root of a negative number is imaginary, right? So if this discriminant was negative, I would say no real solutions. If the discriminant was 0, then I would say the square root of 0 is 0, and it doesn't matter if I add or subtract 0, it doesn't change my answer. So if my discriminant was 0, I only have one real answer. But right here I have a positive discriminant value. So how many answers do I have? 2 real answers. So to answer this, they want the discriminant value, that's 289, and how many real answers? 2 answers. 2 real answers. How do I know there's 2 real answers? Because the discriminant is positive. Okay, now if that confuses you, let's go back to the quadratic formula over here on the side. So we have the quadratic formula here, and I did the discriminant in red. So it doesn't matter what B and A is. If I calculated my discriminant and if I ended up with a positive number, right? And I did end up with positive 289, right? So if you end up with a positive number, the square root, whether it's a perfect square number or not, you're going to get an answer, right? And if you add that answer, it's going to produce an answer. And if you subtract that answer, it's going to produce a different answer. So you really end up with 2 solutions.
So if you have a positive number, you're always going to end up...
If you have a positive discriminant, you're always going to end up with 2 real answers. If your discriminant is equal to 0, then the square root of 0 is 0. And it doesn't matter if you add 0 or subtract 0, you're only going to get the same answer. So you only have one answer if your discriminant is 0. Now, if your discriminant is negative, when you're doing the quadratic formula, if you have a negative 9 in here, you're going to get stuck because the square root of negative 9 is 3i. It's imaginary. If you try that on a calculator, it'll say error. So if your discriminant is negative, you say no real solutions. Yeah, no real answers. And visually, that just means how many times it crosses. If your discriminant is positive, you get 2 answers, which means it crosses at 2 points. If your discriminant is 0, it means you get 1 answer, which means it just touches the x-axis at 1 point. If your discriminant is negative, that means that your parabola doesn't cross the x-axis at all. Jumping to number 18, state the discriminant, then determine the number of real solutions. Wait a minute. Well, that's the same exact instructions as 17. All right, so let's do the same exact thing here. Let's add 30. Add 30. Let's rewrite it. 2x squared plus 15x plus 30 equals 0. Now we could identify our A value is 2, our B value is 15, our C value is 30. And we could plug it into the discriminant B squared minus 4 times A times C. Now remember, this is inside the square root, so we're not using the square root here. We just want the value that we end up with. So in order to appropriately find the discriminant value, we're going to replace the B and the A and the C with parentheses. And then we're going to plug in those A, B, and C values. The B is 15, the A value is 2, the C value is 30. So with the calculator, let's go 15 squared, and that's 225. So 15 squared is 225. And now notice I have minus 4 times 2 times 30. On a calculator, 4 times 2 times 30 hit equal. That's 240. So that would be a minus 240 because it's negative. Minus 240. So we end up with what as the discriminant? We end up with negative 15. So our discriminant value is negative 15. Now, what does that tell you? How many times will the parabola cross the x-axis?
0.
No times at all, right? How many answers do you get? No real answers. You get imaginary answers if you were to do the quadratic formula. So the multiple choice answer we want is that the discriminant is negative 15 and no real answers. Okay, let's try one more of these same type of problems. Number 19, state the discriminant, then determine the number of real solutions. So let's first again set the equation equal to 0 by adding 9. Let's rewrite it. 4x squared minus 12x plus 9 equals 0. Now we could identify the A value of 4, the B value of negative 12, the C value of positive 9. And the discriminant is only the inside of the square root, not the square root itself. It's just the B squared minus 4 times A times C. And when we use it, let's plug it in with parentheses. So our B value is negative 12. That goes right in here. The A value is 4. That goes right here. The C value is 9. That goes right here. And they want us to determine, state the discriminant. So they want the actual answer here. Negative 12 squared, negative 12 times negative 12 is 144. And then I have minus 4 times 4, that's 16 times 9. And on a calculator, let me do that. 16 times 9, we get 144 as well. So we have 144 minus 144. Whoa. Yeah, 144 minus 144. So what's the discriminant? 0. So the discriminant is 0. How many real answers does this have? 1. Right? Because the discriminant is inside the root. If you were doing the entire quadratic formula, you would do the square root of 0, and you'd have the plus or minus right in front of it, and it doesn't matter if you add 0 or subtract 0. That's not going to produce 2 different answers. It only produces 1 answer. So 1 real answer. I forgot the end. 1 real answer. There we go. So 0 is the answer as the discriminant, and your equation really does have 1 real answer. So those were the 3 types, number 17, 18, and 19. I'm going to end this video right here, and we'll pick up on number 20 on the next video.